Welcome everyone to session Energy Upgraded, Scaling Building Renovations for Decarbonization. For those of you that are looking to receive continuing education credits from the AIA, here are your learning objectives and description of the course. This information will be shared with you post-teach-in. You will have an email from us explaining the form to fill out to get your AIA credits. So we have recognized that you've attended and will help you to complete your CEUs after the teach-in. I'd like to welcome you and introduce our two speakers. First off, I'm Vincent Martinez. I am the moderator for today. I'm the Chief Operating Officer of Architecture 2030. Our first speaker will be Martha Campbell. She is a principal in the buildings area of Rocky Mountain Institute. And we also have Kevin Bates, President of Sharp Development. I'm very excited about this session. It's one near and dear to my heart, and I think you're going to be blown away by the presentations today. So with that, I'm just going to go ahead and pass this over to Martha. And I want to note that while we will have question and answer at the end, if we don't get into any of your questions, we will be following up on the website with written Q&A. So all of your questions will be archived, and we'll work with the presenters to have written answers that will be archived on the website after the teaching. Go ahead, Martha.
Okay, thank you, Vincent, for that introduction. And I'm Martha Campbell from Rocky Mountain Institute, and I will be speaking to you about Realize, which is a Rocky Mountain Institute initiative focused on decarbonizing existing buildings. So today we'll kind of first kick it off with what is Realize, and then I'll kind of talk about the kind of four major strategic pillars of the Realize initiative. So I'll start first by just framing the problem, and I'm going to be speaking about retrofits. But before I take you down that path, I kind of want to seed your imagination with what if you walked into a Verizon store and you went up to the front desk and they said, okay, here are all the different components to your cell phone. Pick out which components you want for your cell phone. Now we need to pick out your the cell phone tower that you'd like to have your service routed through, as well as the frequency of the signal. And then also, please come in with your $1,000 of financing for your, $1,000 smartphone. If it was that complicated to get a cell phone, we might not have seen the level of adoption that we have seen for smartphones today. And the reason I use this analogy is this is what we're asking people to do when we ask them to retrofit a building. And it's just not conducive to scale. So what I'm about to show you is a solution that we think addresses some of these issues that they've developed in the Netherlands, and it's an inspiration for our work. And this video is basically going to show you a zero net energy retrofit that was conducted in a day. This was done by a construction firm in the Netherlands. This guy is taking a 3D scan of the building to make sure that those wall panels that you just saw get put in exactly the right place so that their pre-installed windows and doors fit right over the existing windows and doors. This has been a huge area of innovation for an organization called Energy Sprong. And the idea is that you kind of have these system of parts that you can pre-manufacture and pre-design so that you can just very quickly come in and install thousands of units of these systems on very similar buildings. So there goes that pre-integrated high-performance wall system. It has high-performance windows and doors. That big, long, kind of rectangular white shaft that you saw earlier is an integrated set of mechanical systems. That guy's kind of in there right now. And so that has domestic hot water, heating and cooling, ventilation, a smart inverter, and controls. Kind of shows you the high performance roof system that they're putting on. It has the solar racking already in place, and they've actually gotten it to the next level where the solar is already pre-installed. Putting on some gutters. And like I said, this whole retrofit was done in one day. There is some, obviously some prep work that's required in advance, which, you know, takes a little bit longer than a day, but the systems fit together really quickly. So sorry, I couldn't share the music with you. So we'll do this kind of silent movie here for just a little bit longer so you can see the finished product. This is just a little prefab shed that goes in the back. So the tenants are even getting some extra square footage in the process for storage. And like I said, this building was pre-scanned with a 3D scanner, and that scan went into the building information model that then fed into manufacturing those wall panels so they were the exact geometry of the existing building. So there's the finished product. And you know, you can tell something has happened to the building, so it also makes efficiency desirable. So moving along, as I mentioned, this way of retrofitting buildings was kind of the, you know, this idea came forth from an organization called Energy Sprong, and there are 4 main elements to how they organize the market to be able to provide retrofits in this fashion. One is they aggregate large volumes of demand of very similar building types, and they present that demand to supply in order to get the supply chain to develop those types of solutions and to help bring down the price of those retrofit packages over time. So they've already seen a 50% cost reduction in the retrofit packages over 5 years of this program in Europe. So that's kind of one of the most critical market organizing bodies of work that they do. And then there's a component of this as well that is streamlining the financing, which we'll talk about more later. And then they also were able to help, you know, eliminate any sort of regulatory barriers or hurdles towards the adoption of these technologies, and financing hurdles as well. So, and to bring increased incentives to help prime the pump of the market. So this is kind of the market facilitation model that we are inspired by and adapting for our needs here in the US. So the Realize program at the moment has kind of 3 main bodies of work. Most recently, we were selected by the US Department of Energy to lead an advanced building construction collaborative that very specifically seeks to organize the market like I just showed you at the national scale, and really drive kind of this R&D and manufacturing piece of this so that these products are available in the marketplace. We've had a tremendous, we've had quite a bit of difficulty sourcing those types of products like you saw in the video. Our next major body of work is kind of what sort of started this for us in the sense of market facilitation, which is Realize California. And so we're doing a lot of that type of market facilitation and rolling out a delivery program here in California. And then, you know, kind of to the point that I made previously, that it's been challenging to source a lot of those types of technologies and products, we ended up having to get more involved in the R&D process than we had originally anticipated. And so we're working with a number of manufacturers and partners to start to kind of make sure those products are available here in our various markets that we're working in. So on that note of R&D, let's talk a little bit more about the technologies, just to kind of lay out what those Lego blocks were that we saw in the video. So like I said, we've got these kind of insulated facade panels, what we call the unitized wall systems, that have those high performance windows and doors pre-installed off-site. There's that insulated roof panel with the pre-installed PV kind of being the vision there. And then these integrated mechanical systems that include domestic hot water, heating, cooling, ventilation and controls, and depending on how solar is installed, even a smart inverter. And then lastly, you know, to really fully decarbonize the building, we have all electric appliances. So this is just a picture of some of the different wall systems that they have in Europe. These are all in the Netherlands. And so you see that you can get kind of a variety of styles and looks. The highest building I think that they've done thus far was 7 stories. So we're starting to see them continue to innovate into kind of new typologies. They started out on these kind of low-rise row homes. So the other piece of the kit, which is requiring a pretty significant amount of innovation, is this set of integrated mechanical pods. You know, we thought, oh, we can just maybe start to source some of these products from overseas, and obviously, you know, there's a lot of nuances to adapting mechanical systems to new climate zones and new markets, and you know, with different ways of even like how the electrical loads work and things like that. So anyhow, this is what they look like, these pods. On the left-hand side, you can see there's a heat pump in the top left corner. There's smart inverter kind of in the middle on the top. You've got some ductwork going into the ERV down in the bottom, a little hot water tank on the bottom left, and then kind of your controls in the middle. The other 2 images are just showing you kind of how the pods vary depending on if they're being installed inside the building or outside. That middle set is to be installed inside. On a lot of the buildings in the Netherlands, they're enclosing balconies and creating more floor area so that they can put some of these systems inside. And it actually makes retrofitting the existing building a lot easier when you just enclose the balconies. And then on the right, you have kind of that typical outdoor install of the pod. On the demand side, kind of where we're at, I'm going to use an example from California, but what we've found to be pretty effective, and if we're thinking about standardization of the solution, is really understanding the building stock and segmenting it into these typologies that you can kind of define a very consistent retrofit package. So we did a typology study on California's multifamily housing. There are about 3 million multifamily units in California. And those are kind of made up of these kind of quintessential styles of low-rise wood frame construction, stick frame construction. And so we kind of have this townhouse style, the garden style, and the loaded corridor is the main categories. And one thing to just kind of draw your attention to is that it's pretty close to being a pretty even split, but there's a significant amount of these buildings were built before Title 24 existed. So, a lot of the buildings don't have insulation in their walls. So we're kind of having to innovate to both kind of groups of buildings, groups that have insulation and groups that don't. So that's going into these retrofit guidelines that we're developing. We also looked at the kind of existing mechanical systems that were in these buildings and have defined our retrofit guidelines by those kind of most common HVAC systems as well. And so all that's culminating in doing several demonstration projects. These are all affordable housing. We're working specifically in disadvantaged communities across the state. And in partnership with Association for Energy Affordability, who is the Low-Income Weatherization Program Administrator. And so we're kind of combining resources from that program and the California Energy Commission to demonstrate some of these more standardized retrofit packages on some of the buildings in these complexes, and then also just some of the kinds of technologies that we'd like to see more pervasively adopted in the LIWIP program. So these are some of, like I said, our demonstrations in disadvantaged communities across the state in California. And then at the same time, we have a Department of Energy pilot project in Boston, Massachusetts. And we did a very similar typology study in the Northeast and Midwest, looking again at multifamily. We've been focused on multifamily housing and found that one of the most common building types were buildings that had more than 30 units and were mid-rise structural masonry. And so this building, the brownstone in the middle here, is the Eva White apartment complex, where we'll also be doing more of a mid-rise demonstration for those climate zones, the cold and very cold climate zones. So kind of the next piece of the puzzle, right? So we talked about technologies and starting to kind of cultivate that demand first, just with the retrofit projects, right? We really got to kind of show what this looks like for owners so that we can start to aggregate much larger volumes of demand to negotiate down prices with supply and really get the market moving. But one of the kind of critical areas for innovation has been around the financing. And we are very specifically focused on affordable multifamily housing in the US, which is sort of a very complex market segment, but one that has kind of been a tough nut to crack. And we think that the Dutch have done some interesting things. So that kind of cell phone analogy I gave you at the beginning applies here in the sense of there's a couple things going on. So the Dutch have basically allocated risk to the two responsible parties. There's system risk. So like, will the HVAC system actually work properly? Will the unitized wall system, be installed properly and perform on an ongoing basis? So that's kind of the infrastructure risk. And then there's the behavioral risk piece of it. And this kind of performance structure that they've developed in Europe has a relationship between the owner and the tenant where the tenant has an energy budget. And as long as they stay within that energy budget, they don't have any sort of excess utility bills, but they do pay an energy service plan to the owner. Now, we can't do that in the US, so we're coming up with a new model. But the same kind of structure, it will be a very similar structure. If that tenant basically decides, hey, I'm going to go beyond my energy budget, all of these buildings are net zero energy, so the amount of solar they produce, if you in a net energy metering construct, will offset the load that they consume. That's how you keep their bill below zero. If they consume above that solar generation, then they have, they're still connected to the utility and they pay, whatever that excess was in consumption. Now, on the left-hand side where you see it say solution provider, there's a performance guarantee between that solution provider and the owner. And that is to ensure that the systems are performing and that if there is an overage, that it's from a behavioral issue, not from a systems issue. And so that solution provider procures like ongoing real-time monitoring services from this energy pod provider that we saw earlier. So the manufacturer of the energy pod instruments the pod so that information can be collected about how those systems are performing in real time. And then there's some other sensors in each unit, like CO2 sensors and temperature, obviously for the thermostat, to kind of understand, like if the window's wide open, right, then you're going to see a big drop in CO2, to kind of try and diagnose and troubleshoot when issues are behavioral versus performance from the system. So all of that is kind of the construct for how they ensure that the systems are performing and risk is appropriately managed. And we are emulating that. This is just an example of our kind of initial thinking on the specifications for the energy budget here in California for a specific category of buildings in a specific climate zone. So we're kind of learning about through this process, like how do you set all of these parameters to kind of achieve what the Dutch have done. And then just to conclude this section, this is just kind of showing you like what are the implications of that? Why are we talking about performance monitoring when we're talking about finance? Well, because all that rolls up into what an owner can underwrite to fund one of these projects. So historically, right, you have the tenants paying. You have the split incentive issue, right? The tenants are paying their energy bill to the utility, the owner captures rent, but they can't capture those utility bill savings. On the right-hand side, in California specifically, we are trying to increase building owners' ability to capture those savings through a mechanism called the California Utility Allowance Calculator. And we can model what the predicted savings are for that building. The owner can then adjust their rents. They can take that rent and sew it into their net zero energy investment. We also want to make sure that the tenant captures some of those savings as well. And then lastly, if the tenants have an overage, then they would pay, some sort of a utility bill, or maybe that's even just their fixed charge. So this is kind of the new structure of expenditures and where those resources are going in the realized model.
Martha, I'm afraid I'm going to have to cut you short. I know you have the policy section, but we need to move on to Kevin's presentation.
Oh yeah, sorry, I didn't mean to go so far over. I have one slide. All I have to say about policy is we've been working on the stimulus packages, but there is a lot of work to do on bringing more incentives to this. So I'm done.
Thank you, Martha. Appreciate that. We're going to move on to Kevin, and then they both generously agreed to stay on the session to answer additional questions if you'd like to hang on. The Spanish interpretation, unfortunately, though, will have to end at that point at the end of the session. So Kevin is up, and I will spotlight you. Thank you, Kevin. Thank you, Martha.
Great. Thanks, Vincent. What I want to talk about today is how to renovate existing buildings to zero net energy, operational carbon neutrality, with a very, very strong emphasis on the health and wellness of the occupants in a manner that's more profitable and cost effective than building to meet minimum code. And so what I want to touch on is our design approach, which is a holistic integrative design approach. We'll talk a little bit about what that means and give some examples of how we carry that out. I also want to talk with the engineers, architects, any of the folks listening that are trying to convince building owners to drive their buildings and renovations in this direction and in this manner, to give you some language that'll help resonate with those building owners and hopefully help your cause and being a little more effective at convincing them to go in this direction. And then at the end, we'll also end up going through some financial analysis as to how these buildings actually perform relative to buildings that are built just to meet minimum code. And that's not advancing. So design philosophy, what does a holistic design mean? It means we want to bring everybody together at once. We'll have everybody in the room when we're doing our design of these buildings. So what we don't want to do is design in a silo, right? And say, I'm going to put solar on the roof. It's going to have a 20-year payback or a 5-year payback. I'll either do it or I won't. My LED lighting change out, 5-year payback. I'll do it or I won't. What we want to do is, I can't tell you what the insulation payback is or the payback on the ceiling fans that move air across the body in the summertime and lower perceived temperature, or what the payback on the electrochromic glass is. But when integrated, they're all very critical pieces and parts of doing this thoughtfully, cost effectively, with the health and wellness piece woven in. And we'll go through some examples of what that means and how that's done. And the examples we'll talk about are things you want to do are taking what nature gives you for free and maximizing that with your materials, your methods, and your technology. And then at the same time, we want to have products and materials serve multiple purposes, so that we begin to get a domino effect and a cumulative effect that's going to help with our economic picture. So on the integrated design piece, what that means is having everybody in the room at once. So we'll have our architect, our mechanical engineer, plumber, electrical engineer, structural engineer, contractor, marketing people, the property managers that are going to live with this project. Everybody that's going to touch this project is going to be in the room at the same time. And so how that conversation might go with one aspect, for example, this is a racquetball court that had no glass at all. It had 2 storefront doors, and that was glass, and that was it. The rest was solid concrete walls. And as you can see, we punched a lot of holes in the building. So when we're designing and figuring out how much glass and that kind of thing we want to do, I would look to the structural engineer and have them outline the amount of concrete we could punch out and where we can have punch outs without structurally impairing the integrity of the building. And then I might look at the architect and he'd say, well, I want floor to ceiling glass 5 feet wide in that section. I'll look to the marketing guy, say, yeah, I want to fill that whole cavity with glass. And then I might look at the mechanical engineer, and the mechanical engineer say, yeah, but that glass versus insulated concrete is going to lower our insulatory value and make our EUI, our energy use intensity, go up, so you're going to need more solar. And the daylight engineer might say, yeah, and you're going to get no value of the lower 18 inches on natural daylight for the space at all. Now look at the contractor, and he's going to say, well, here's the difference in cost, Kevin, between the insulated concrete and the glass, electrochromic glass versus low E glass, depending on the elevation. And this discussion will go around and around until we figure out exactly where those vectors of efficacy cross, to maximize the value and the utilization of the building. And so that's what an integrated design conversation looks like. And the engineers will have a much larger role in this than they normally would, as opposed to how I used to do it, which would be to hand it off to an architect. So I want the building to look like this, and I want the layout and the interior to do that. Architect would design it, ship it off independently to the MEP engineers, and they would, you know, design the mechanical systems and the electrical systems, the lighting systems to accommodate that design, and everything would come back and have been done in isolation of each other. And we don't want to do that. Everybody's got to be at the table at the same time, and it makes for a much, much more efficient process, as you'll see later on. So an example of having one product serve multiple purposes, the larger picture, you can see this is a building we're going to look at the economics of in just a minute. This is the very first one I did. We've completed 6 net zero energy buildings and are on 7 and 8 right now. And as you can see, we have a lot of hard surfaces exposed, and I wanted to have an acoustical fabric in the ceiling to hide the insulation so that it would help deliver exceptional acoustics, part of that health and wellness aspect. So this fabric that we found is panel fabric made for movie theaters to absorb sound specifically, so it gets the acoustical. It's got reflective capabilities, so our uplight gets distributed very evenly across the space. It's very attractive. It's got 150 pounds of tensile strength, so we can bring it up very high, stretch it, hide it between the beams, hide the cap sheet and the insulation, also expose this beautiful wood structural system so we have some connection to nature. And so we've got one product serving multiple purposes, and we did it in a way that was 20% less expensive than a T-bar drop ceiling. The inset photograph is of electrochromic glass, and the multiple purposes that that serves is it not only gives me 6 to 8 times the insulatory value of a low E glass, but it also eliminates all glare that comes through the glass, so I no longer need blinds, so I save cost on the blinds. Because I don't need blinds, I've got 24/7 connection to the outdoors, so views and connection to nature from a health and wellness standpoint for the occupants, and it enables me to also control my light levels. So one product serving multiple purposes. So we're talking about taking what nature gives you for free and enhancing it. This is that same building, midday, no lights on, no power going, before the renovation. We then developed a skylight that we wanted to naturally daylight the space with, where the angle, the aperture, the orientation of the skylight, the shape of the shell, everything in that design was exactly where those vectors of efficacy cross again between maximizing the harvesting of daylight and minimizing thermal gain. And this is what we ended up with. This is that exact same building from the exact same place at the exact same time of day after the renovation with no lights on. So this is before the renovation with no lights on. This is after. This is 100% for free for the remaining term of the building's life. So what did that end up meaning economically? Well, we hard bid this project as though we were building it to meet minimum code. And we said, okay, it's going to cost us $49.84 a square foot more to renovate in this fashion, but we drove operating expenses down to a point. We got rents that were above anything that had ever been achieved because we had differentiated our product from everything else on the marketplace. And at the same time, we leased it more quickly. Some of our methodologies added square footage. So the net effect of it was, had we sold this building the day after it was completed and occupied, we would have recovered that $49.84 a foot and picked up an extra $100 a square foot of additional value. And so what this means is this extra value goes into further enabling us to renovate existing buildings versus making the decision to putting them into the landfill. This is that building we talked about that was a racquetball court after the renovation. When we analyzed this building as though we were going to renovate it conventionally, the decision was economically, it made way more sense to scrape the building and throw it in the landfill and rebuild a new building. That was what was most profitable. And about 30% of all the carbon footprint of the life of a building is in the construction of the building itself. And so with these economics that we just went through, what those end up meaning for us, we've got an extra $120.29 a foot that we were able to plug into our analysis of renovating the existing building. And it turned out that it made more sense to renovate it this way than to send it to the landfill. So we've talked about all these methodologies about, you know, having your products maximize what nature gives us for free, having products serve multiple purposes, all these kinds of things, how the economics play out. So let's take a quick look at what it means with the health and wellness aspects that have always been in the background of all of this. So Stoke is an engineering environmental consulting firm here. They basically analyzed over 60 empirical reports and studies that were done on the health and wellness aspects of an interior of a building. So people working, and it went from students in the classroom to people in corporate environments all across the board. And they tested higher carbon dioxide levels versus lower, better acoustics, better thermal comfort. So if you're in a healthy building, what it meant to these people's productivity, their retention span, their health, and how many sick days they would need. And they then took that and were able to quantify that and apply it back to a 150,000 square foot building with the assumptions that you can see here on the screen. And the net effect of that was for 150,000 square foot occupant, it increased their profitability conservatively $2,780,000 a year. That's an amazing number. And so when we combine that health and wellness value to the tenant with what we're doing as a building owner to the building, these numbers become staggering. So they get $2,780,000 a year of more profitability. We've already said we added $100 a square foot of value. When you take that $2,780,000 and put a market price earnings ratio to that, it adds $41.7 million of market cap value to that company. We add that to our $15 million. After we've recovered the $7.5 million we spent to deliver this type of building, we pick up $56.7 million in value. And these numbers below the line here are things that I did not include there, but they're real numbers. The $1,248,000 is investment tax credits, accelerated depreciation, that kind of thing. We will have lower reserve requirements because we've got smaller HVAC units that are on less often. And then I'll go through in a couple of slides the tenant retention piece that makes up that $12.9 million in value. So this $56.7 million of additional value for spending $7.5 million, as staggering as it is, we're not quite done yet adding value. So that was with an existing building that was not occupied that we did on a spec basis. For those of you that have portfolios where you've got a lot of buildings that are primarily occupied, I want to walk through this scenario. This is an 82,000 foot building in Fremont that I purchased in 2011, did a conventional retrofit to it, put a tenant in place, signed a lease, 15-year term, put a 10-year fixed rate loan in place. All the value's been added. We're done adding value. There's no more that can be done. We came back to this building in 2017, 2018, and while that tenant was running 2 shifts, 16 hours a day, we retrofitted to net zero energy. And you can see what we did to it by reducing the EUI on some of the improvements, creating the generation, and what the economics of that look like for me as a building owner. I spent $3.3 million to do this retrofit. Our tax incentives after a year, we were into it for $1,966,000, and we saved $421,000 in power. I went to the tenant and I said, hey, if we do this, how about if we reduce your power bill from $421 to $400, we increase your rent by $400,000 a year, flatline that, so I eliminate all increases in your PG&E rates, so you got, which is, by the way, one of their 2 biggest variable costs. So your power is going to be flat and lower, and you're insulated from all those increases for the rest of the term of your lease. They were thrilled. And for me, that $400,000 of increased rent capitalizes out at $6.1 million in additional value. So I spent $2 million to pick up $6 million after the fact, and you can do that to any of the existing buildings in your portfolio. And the, oh, by the way, on this was it's the equivalent of taking about 95 million gallons of gasoline off the market from an environmental standpoint. So the impact on the tenant we've kind of talked about, and the impact on the ownership. Tenants' power rates are flatlined, PG&E rate increases are gone away, that variable cost has gone away. They were able to bid long-term contracts more competitively because they don't have that unknown that they need to allocate for. And for me, I now have a tenant, because of all these savings, it's gonna be very difficult for them to leave that building. And then if we're in a down market and they're still just gonna flee to low rent, I've got 45 to 50 cents a square foot of power that I'm getting for free that's been fully paid for after 5 years. So I can split that with them at half, and what the market rents for this particular building are, I can then offer them 15% below market rates with the power rate surety and still have a rent that's 15% above market rents. And so it gives me financial stability with my lender as well. Why is it important to have a sticky tenant? So if you go through this list of items here, this will show what it takes and what the process is. If you lose your tenant, to get that tenant back and re-tenant the building, you're going to lose rent for a year, minimum 36 bucks a foot. repay a commission on a broker to put the tenant in, and minimum have $40 a square foot of interior improvements. So you're looking at $85, $86 a square foot. And the value of these buildings are $250 to $300 a square foot. So that can be all of the equity in the building if you lose your tenant. So having that tenant be sticky is very important. So what are our takeaways from all of this? Well, we've demonstrated it's significantly more profitable for me as the building owner. I've got a better credit strength because I've made my tenant so much more profitable. That's going to lower the cap rate, make my lenders' collaterals more solid and stable. So the lender's happy. I get better loan terms down the road if I ever want to refinance. I've got a diversified or a differentiated building stock from everybody else's. So I've reduced my risk while increasing my profitability. And from the tenant's perspective, we've got tenants working in a much healthier environment. They're much more profitable. It's going to be very hard for them to leave. Operationally, they've differentiated themselves from all of their competition. At the end of the day, they're being a good corporate citizen and meeting their ESG goals. So the last question I would have is, if we know this and we know how to do this, why would we continue to design and build any other way? And with Vincent, I'll turn the screen back over to you.
Thank you very much, Kevin. Great presentations by you and Martha. We're going to go ahead and stop the presentation mode. I'm going to turn off the spotlight feature so you can see Martha and Kevin. We had a few questions come in that were already answered in the written form, but since we do have a few minutes here, why don't we go ahead and take the time to answer them? But I just want to note we have about 3 minutes left remaining in this session, and then the Spanish interpretation will stop. But again, if you'd like to stay on the line, Kevin and Martha have agreed to answer your additional questions that might come up if there are any. The main questions, I think, Martha, that you answered based off of the question and answer were really about questions around how does Energy Sprong's system work for previous thermal bridging issues or air sealing? Maybe you could answer those out for the audience.
Sure. So all of the systems that they designed in Europe were designed to meet passive house levels of performance. So they have to address thermal bridging, and because you are laying them across the facade where there might be existing thermal bridging issues, you actually tremendously improve thermal bridging issues in the building. And then they also kind of serve as an air sealing mechanism in and of themselves. Their joints are designed to basically connect in a way that doesn't allow for air leakage. So they're achieving passive house levels of air tightness. So the panelized system is actually kind of a huge innovation in that sense around air sealing, and it's really great when you kind of combine all of that into that that one unitized wall panel.
Thank you, Martha. And then the other question that came up was for you as well, and it had to do with the cost of electricity from electrification for low-income households. And given that your typology is mainly low-income households, can you answer that for the audience, please?
Absolutely. Obviously in markets where you have a really big differential in between electricity and natural gas, with electricity being more expensive, we call that the spark spread. That makes electrification, much more challenging. There are a couple of ways to overcome that depending on the market. So if you have net energy metering and the cost of solar, if you could get the cost of solar to be dramatically less than, utility-based power, then you can reduce your loads, combine with solar, and do net energy metering, and that definitely makes for cost-effective electrification, in some instances even profitable electrification. We have that here in California in certain instances. But yeah, reducing load is a critical part of this. Like if you just go into kind of a low-performing building and put in, a heat pump, and you haven't actually reduced like the heating and cooling demands of that building, you will see a pretty, you'll actually end up having a massive increase in your utilities. So that's one reason why we believe this efficiency, integrating this with efficiency is really important, because I know there's kind of this narrative going around right now where electrification is something different than efficiency, and it's kind of like, these things really need to go together. Not to mention like the implications on the grid when you start electrifying all of our cars and our buildings, right? What are going to be the impacts of that? So we believe in integrating all those things. We're all about integration.
Great answer. Thank you, Martha. So we officially have to conclude this session, just so you know. If you would like to join the next session, it will start in 4 minutes. You just go back to the CarbonPositive website, to the agenda page to click on the next session. Again, we're going to leave this open. Martha is now the host, and Kevin, there is a question that I think is directed to you in the question and answer. I'll lead it, but then I'll drop off. It's, how do you incentivize builders to look at the existing buildings differently? Typically, the pushback from builders is that it's easier to demo and get new versus retrofit or fix existing. And I'll let you take it from here.
Yeah, part of that, is the timing and the entitlement process, and what it takes, and the lack of surety of getting from A to B through the entitlement process, which here in California has become very arduous. So that's one. Two is time to market. We know what the market is today, so the longer out you are, more risk, more uncertainty. And three is we're able to utilize the existing structures. The way we renovate these buildings, most of the money's going into the shell, and the way we're doing it, it actually is more cost effective to work with the existing shell than it is if we were to scrape and build new ground up. So the economics actually, from a profitability standpoint, when we've compared the two, even taking and implementing all of the net zero energy, carbon neutrality aspects into a new ground up shell, we're still finding that retrofitting the existing buildings in many cases is ending up being more cost effective and more profitable. So the profitability aspect is what speaks to the owners.
Okay, I'll go here. Sorry, another question for you, Kevin. If you can explain what type of windows had been used into the renovation tenant building, how much costly compared to low E? How much more costly?
Yeah, the electrochromic we use on the west, southwest, and southeast side, basically on the sun elevation sides, we'll use low E. We only use it where we need it. We never use, the electrochromic, we never use that on the north side. And, the glass is running around $56 a square foot, as opposed to $13 to $15 a square foot for a solar band 70 or a solar band 90. So there's an additional cost there, and another small additional cost for the wiring. It's a DC line, a low voltage line that needs to be hooked up. And so there is an additional cost, but what we found from the insulatory value, from the ability to control light levels and all those kinds of dynamics as a package, it really makes sense to use. And that then gets back to the holistic mentality as opposed to looking at things in silos. The racquetball court that we did, it's the first time out of over 50 projects that I've developed that I've ever had a tenant come in, and the tenant was First Data. It's a $2 trillion company, where they actually populated the building based on light preferences, as opposed to the engineering department is here, the legal department's there, or accounting's over here. They actually populated the building based on their light preferences. So people that were working on their computers a lot wanted a lower dim tint on the window, a darker window. And some of the legal people and salespeople that were reading a lot of contracts that wanted more light levels, wanted a level 1 tint versus a level 3 or 4 tint. And so it really gives you an advantage to being able to control the light levels in the building and help the experience for the occupants as well.
Another one, was the added 2.78 million profit calculated before or after occupancy and use?
After.
Okay. Kevin, do you have resources to talk to building owners about these benefits? Do you give presentations?
Yeah, I mean, I could talk to building owners anytime about the benefits and how we do it. I can connect them with all the resources that they need. The folks that, after doing 6, 7, 8 of these, we've pretty much got it down who the best engineers and who the folks are that know how to do this really, really well. And I'm happy to get with anybody and help them understand how it can be done. It's not as complicated as it sounds. I know it sounds complicated, but once we figure out how to do all of this, it's pretty easily replicated. And, the building materials and methodologies that we're using, insulation, skylights, thermal mass, ceiling fans, LED lighting, none of this is rocket science. And so we can integrate that with a relatively straightforward open source software system that acts as our building management system for folks. So absolutely happy to help anybody that needs the help.
Sorry, I'm just, I think we got a couple more. Here's a question for me. Here in Seattle, we're piloting a program called Energy Efficiency as a Service, where we, the utility, are going to collect the value of the savings from the customer and paying that to the efficiency developer. Which other entities have you seen functioning as collection payment agencies? So you're doing, I think that sounds like MEETs, metered energy efficiency transactions. And we've been looking at MEETs as well. I think if this is your question, we haven't really looked, we're very restricted on the affordable housing side of like who can collect money from tenants, which has been kind of a major barrier around solving the split incentive issue for us. I think MEETs has a lot of potential. I know that there were some discussions with PG&E about that structure, but we need an IOU to really buy in here in California for us to use this to scale rapidly. So that's my answer to that question. Would love to talk further if you guys have made big breakthroughs on rolling MEETs out. Sorry, couple more questions on retrofitting. I'm wondering about the party wall in the townhome. Okay, in the video you shared. It seems like the shared wall between one retrofitted and one not retrofitted townhome would be a large surface area where energy could be lost. Yes. That issue, we haven't really gone into in depth with Energy Sprung. I'm not quite sure how they dealt with it, like if they did some sort of air sealing mainly on the inside wall to deal with that, is what I'm assuming. It hasn't come up as a major issue. Those are all also structural masonry buildings. I mean, there's some thermal bridging going on there, obviously, but I'm pretty sure they have drywall on the inside. So that's kind of my winging it answer, but great question. We know that's a major issue that will have to be considered in these, kind of one-off retrofits. Otherwise, if you can just encase the whole building, you can deal with some of the issues in between units. And then the next question was, what has been your experience renovating buildings that need seismic renovation? We are literally in the process for those demonstration projects that you saw in California. We just came out, we've been working with RDH, and they are helping kind of us do this research on what the seismic constraints are of the existing structure and like how much weight can they carry for a new roof or a new wall system. And that is a major design constraint here in California. If the wall system is too heavy, then you have to do a full seismic retrofit, which likely would be cost prohibitive, although we're still looking into that as well, if there's kind of some dual benefits there. So that's kind of the status of that research right now. But very lightweight wall panels is what's required. So I think those are all the questions. Any other comments, Kevin, or shall we call it a day?
Call it a day. That was good. Thanks for hanging in there, guys.
Thank you, everyone.
Thanks, everybody.
Bye, Kevin.